In section 3.4, we want to discuss measures of position and the 5-number summary. Now, your measure of your position is a measure of where the score that you're looking at falls in relation to the whole data set. So let me give you kind of an example of how this would work. So suppose you get an exam back for this class and you find that you got a 70%. How do you feel about that score? Well, it depends on personality, of course, but in general, students that get a 70% are not very happy. Even though it's passing, they're not happy because it's the lowest possible passing score, and they know they have to make it through another exam, right? So this is the lowest possible passing score. All right, so that's just a raw measure of what they're feeling about their actual score, right? So their score is 70, they're not feeling super great about it, right? But then suppose that I further inform you that the mean on this exam was 60. Now how do you feel? Well, feel a little bit better, right? Because the mean, remember, is the average, right? It's the center. And if you know that the center was 60, then you know that you scored better than about half the class, or even a little bit more, right? So did, right? So that's feeling pretty good. It's not exactly half, but you figure the average is the center, so you figure roughly 50% or half the class will be below you. So you're putting yourself in a measurement of position. You're trying to think about, where do you lie in relation to the rest of the group? Right? Whenever I give back an exam, that is the first thing students want to know is what was the average, because they want to make that comparison. They want to be able to know where they're falling in relation to the group. All right. Now suppose I further inform you that the standard deviation on this exam, which is a measure of spread, was 10%. Now what do you think about your score? Well, let's think about this. You're thinking you're doing pretty well, right? Because let's find your z-score. The actual value you got was 70. If the mean was 60 and the standard deviation was 10, 70 take away 60 is 10. 10 divided by 10 is 1. So you're 1 standard deviation above the mean. In other words, your z-score is 1. And the formula for z-score is down below on this page. You can see you take your value, which was the 70, that's what you actually scored, minus the mean, right? And you subtracted those. So you put those in parentheses if you want to think of it that way. Technically, this division bar here is a grouping symbol as well. And you divide it by 10. So now you did pretty well, right? Let me pause and write this up. So now you scored better than about 60 to 70% of the class. That can vary a bit depending on the shape of the distribution. Was it skewed left or skewed right or whatever? But you did better than just up here. When you only know the average, you only know whether you're above the average or below the average, right? Better than half or worse than half. And even the half isn't perfect, right? Depending on the shape of the distribution. But once you know you're 1 standard deviation above the mean, now you know you're even better, right? You know that you are not only better than half, but you're better than around 60 to 70%. But suppose I said instead tell you that the standard deviation was 5%. Okay, so I messed up. The standard deviation was not 10, it was 5. Now what's your z-score, right? So now you're gonna give yourself a little party hat. You're gonna you're gonna have confetti, right? Woo! Now why? Well, your score is still 70 and the mean was still 60. But instead of dividing it by 10, we're going to divide it by 5. So 70 take away 60 is 10. 10 divided by 5 is 2. So now you're 2 standard deviations above the mean. By the way, the 1 and the 2 don't have any units. They're not points. They're not anything. They just, what it means is the number of standard deviations above the mean you are. So now you know you did very well. There, I wrote that up. You know you did better than most of the class. That most could vary anywhere from 75 to 97. It doesn't really matter for you at this point. It's just you know you did better than most of the class, and that's great, right? So you still scored a 70, but your relation to the rest of the class and the rest of the students changed. And that can change how you feel about your score, right? That's why students always want to know, what was the mean, what was the standard deviation, etc. And the z-score can tell you how many mean or how many standard deviations above or below the mean you are, right? That is what the z-score does right here. Okay, so the general formula is right here. This is what we were using up above. Now, technically, if you have sample data, it's this one, and a population data, it's this one. But it doesn't really make any difference. Either way, it's the value you have, which is your x, minus whatever the mean is, either mu or x bar, depending on if it's population or a sample, and divided by the standard deviation, which is either sigma or s, depending on whether it's population or sample. Okay, so it can tell you whether or not you're equal to the mean, below the mean, or above the mean. Now, these two scores are both above the mean because you scored a 70 and the mean was 60. So if your value is positive, it means you're above the mean. Now, what about being equal to the mean? How would that work? Well, let me just give an example down here. If you scored the mean, if your score was 60, then the z-score would be 60 take away 60 divided by 5 or 10. I mean, it doesn't really matter which one's the standard deviation. I'll divide by 5. It doesn't make any difference. So then 60 take away 60 would be 0. And 0 divided by 5 is 0. So your z-score can tell you whether your value is equal to the mean, because if it's equal to the mean, it is 0. All right, what about below the mean? Let me give you another example. If your score was 50, then your z-score would be 50 take away 60 divided by 5. 50 take away 60 is negative 10. A negative divided by a positive is negative, so it becomes negative 2. So this is if you're at the mean, and this is if you're below the mean. So any value below the mean will be negative. Any value above the mean will be positive. Any value that is the mean will be 0, right? Because it's telling you how far away your x value is from the mean. There are no units to z-scores. There's no feet, no inches, no nothing. Right? They don't have any units. And z-scores have a mean of 0 and a standard deviation of 1. We're going to work a lot with z-scores from chapter 7 onward. We generally round them to 2 to 3 decimal places, sometimes 4. There's a particular context where we do 4. But z-scores are very valuable to us, and we will work with them a lot later on in the course.